my name is Andrew. We believe alignment is one of humanity's most urgent challenges. We first need to understand how large language models process concepts. Today I'll show you software we built for mechanistic interpretability, tools that let us see into these models' inner workings. We start in the experiment view. I've already run a number of probes using our guided builder, which populates a data lake with activation and routing data. Here we're looking at token highways, the paths tokens take as they route through different experts. For this run, I've selected positive and negative nouns and verbs. We're coloring the flow diagram by sentiment. The Sankey diagram shows how these tokens flow through these experts. Let's take a look at one. You can see its specialization, very positive, the category counts, and the statistical significance, which we like. That gives us a clear picture of what this expert is focusing on. Now let's look at the color controls. We can add a secondary axis, and with color blending, we start to see interesting combinations. Notice the note here. Visually, it matches what we saw in the expert card, showing that it is handling a mixture of positive words. Now let's move to the LLM insights. Manually analyzing millions of probes would take forever, so we use large language models to help us interpret the data. Here's the prompt we feed in, along with the routing data. The model then performs a set of analyses, identifying network structure, showing how concepts are organized, and so on. At the bottom, you'll notice safeguards to prevent overinterpretation. Okay, it's finished. Let's take a look. And here are a couple of insights from the report that I found were interesting. We have this positive verb terminal with 97% positive and 61% verbs. It's helpful operations, and a negative object sync, 94% nouns, 60% negative, like a dangerous object micropipeline, as the large language model seems to think it is. Now imagine a team of AI agents acting like scientists. Each brings a different perspective. Linguist agents, discordant agents, specialized analysts, all scaffolded to explore in diverse ways. They read insight reports, propose new probes, test findings, and share results back. Before we finish, let's move to the latent space tab. Instead of looking at which experts handle a token, we look at how these tokens are repositioned in latent space. We use clustering to identify meaningful regions and then track how tokens move through them. Here in the mid window, colored by parts of speech, you can clearly see nouns and verbs separating into distinct regions. This separation is significant based on clustering over the first three principal components. And when we look at the trajectories through this reduced space, we see tokens positioned very different. Words like commit, control, describe, verse, seal, horse, or bear. That's very similar to what we've observed with GPT-2, whereby the mid-window concepts are organized into entity words and function words, which then begin to interact more in later layers. So far, we've been analyzing these elements separately. The next step is to tie them all together, giving a large language model or a team of AI agents all of the data at once. That way they can explain not just which tokens attend to each other, but why attention lights up, and how that connects to expert routing and token positions in latent space. That's the full story we're working toward with latent causal analysis. Thank you for attending, and have a great day.